Dear students, in this class we are going to discuss from semiconductor. The topic is electrical conductivity of semiconductor. So listen, so that electrical conductivity, it is represented by the symbol that is a sigma. So we know the general relation, that is a current density is equal to sigma into E. So we should calculate current first, then sigma. So that J value also we can write, that is J is equal to I by A. So first step you must calculate current, second step you must calculate current density, and third one electrical conductivity. So this is the general idea. So see that, so let's take one semiconductor. The length of the semiconductor is L, cross-sectional area of the semiconductor is A. So we know that in that semiconductor that current conduction responsibility electrons as well as holes. So that electrons is when we apply the external potential, so the electrons is move towards to the drift towards to the positive terminal. Likewise, that the holes drift towards to the negative terminal. So according to that, we can say that here two current, you must add two current. That one is electron current, and another one is the holes current. So I can write as that is electron. Generally, the current value, the total current, we can say that is electron current plus the holes current. So this is the general idea we learn from the diagram. So if you observe the current, so already we studied the same kind of diagram in that electricity, but that diagram for conductor. So in that conductor, responsibility only for the electron. So you know that electrons will be drifted to the positive terminal side. So that relations you know. So that current is equal to NEAVD. Okay. So here I is the current. That is N is nothing but charge density per meter cube, and then E is nothing but charge of the electron. A is nothing but that is a cross-sectional area, and D is nothing but that BD is nothing but that is a drift velocity. So this is already you know from the electricity. So the same idea we can follow here. So first I can write for, so you know I is equal to IE plus IE plus IH. So first you find that is IE, that is that current due to electron. So that is IE is equal to, that is electron current is equal to the same model. So we can write NE, that is N suffix E, E into A into then VE. Here NE is nothing but that is electron density per meter cube. Then charge of electron, as usual cross-sectional area, drift velocity of electron. Okay. Then the next one for IH. So IH we can write as, that is the holes current we can write as, that is NH EA into VH. Okay. As usual meaning. Okay students. Now that equation 1 and 2 we can, equation 1 and 2 we can apply in, equation 2 and 3 we can apply in equation number 1. So equation 1 becomes, that is I is equal to, then I1, IE value substituted, then after that IH value substituted, then here commonly we can take that is E in outside. So now the current factor is over. Okay, so first idea over, current factor. Then second one, you know that is current density. Current density formula, you know, generally J is equal to current divided by unit area. So the current value already we found, then after that divide by area. So we can say here that area value cancel. So the remaining term E into NEVE plus NHVH. Okay. So now the second term also over. Then next one, third. Third is that electrical conductivity. So this is the main. This only we are going to find here. So please listen. So we know that J is equal to sigma into E. That is a relation already studied in electricity. Therefore, sigma is equal to J divided by E. J is nothing but you know that is current density already you found, just to substitute here. Then divide by E, unit electric field. Then you know very well, if you observe that here E charge, NE, that is the charge density per meter cube, then V is the drift velocity, then divide by here electric field is there. So you know that relation, that is a drift velocity per unit electric field. Yes, that is mobility. So that is represented by, that is mu. So mu is equal to drift velocity divided by electricity. Okay. So this you studied in electricity. The same thing we can apply here for electron as well as the hole. So here the drift velocity of electrons per unit electric field, this is that mobility for electron. Like that here drift velocity of holes per unit electric field. So this is the mobility of the hole. So now I can write sigma is equal to E into Ne. This term become, that is mu E, that is mobility of electron, then plus NH mu H. Mu H is nothing but that is a mobility of the holes. So this is the general formula, is a derived formula for extrinsic semiconductor. Suppose in the case of intrinsic semiconductor, then what about the conductivity for intrinsic semiconductor? So intrinsic semiconductors, you know that a number of electrons value and a number of holes value should be the same. So commonly we can say that Ni. So therefore Ne is equal to NH is equal to Ni. So the previous equation we can write in the another form, that is Ne, that is equal to Ni, then NH, that is also equal to Ni. So Ni is common, let's take outside. Therefore sigma is equal to E into Ni, then mu E plus mu H. Okay students, I hope that electrical conductivity you understood. Okay, thank you.